Hi. So one of the most common operators that we use in the programming languages is the equality operator. But no matter how common the usage of this operator is, its nuances are still a source of confusion for many of us, especially in JavaScript. In JavaScript, there is something called the loose check, and then again, there is something called the strict check. So in this video, we are going to explore what it means when we have something called a loose check versus when we have something called a strict check. And also we are going to explore how it behaves differently in the primitive types versus how it behaves in the non-primitive types. So let's get started. Okay, let's get started with the loose check versus the strict check in the primitive types. Let's start with how they look like. The loose check is where we have the double equal to signs, and the strict check is where we have the triple equal to signs. That is how they differ in how they look like, how they differ in their behavior. The definition says that in loose check, the implicit conversion of the types is allowed, whereas in the strict check, the implicit conversion of type is not allowed. We'll get to what exactly do we mean when we say that the implicit conversion is allowed. When does the implicit conversion happens? And when it actually happens, what is converted to what? So let's get started here with an example. So as you can see here, I have two variables, A and B. A and B both hold a value of 100. But note that A holds a string really. It is enclosed in quotes. Whereas B is actually a number. So this is a scenario where we are checking their equality through the loose operator because we have two equal to signs, not three. Here the implicit conversion comes into play. Implicit conversion means without the intervention of code, without the intervention of the developer, the JavaScript compiler internally converts both the types into the same type. Now this brings us to the question of what type is converted to what. Should A, which is of type string, be converted into type number, or B, which is of type number, should be converted into the type string? The definition, the rule says that whenever one of the operands that are compared is a non-string, both the operands should be converted into number. So in this case, B, which is of type number, stays as it is, but A, which is of type string, gets converted into the number. So basically, the string 100 is converted into the number 100. Now that we have both the type of both the operands the same, we'll get to the value part. What happens in the value? Because the values are now the same. The types are already same because of implicit conversion. The values are also same, both are 100. Now when we try to run this part of the code, as expected, we get true. Moving on to the second scenario, where again we have A and B as in the previous example is a number, but A is a string 100. Again, we are checking it through the loose check, the double equal to signs. And therefore, the implicit conversion kicks in. B will stay as it is because it's a number, but A will be converted into a number. Okay, let's zoom into this part of where A is converted into a number. What do we mean when we say that A, which is a string, is converted to a number? Is it really possible? Is it really possible to convert a word into a number? Not really. In the previous example, this was actually a number which was enclosed in quotes. But here, this is not a number. It's purely a string. In this case, compiler will say that what you are giving me is not really convertible to a type number, which is why this will get converted into NaN, meaning not a number. So in the implicit conversion step, we end up having A getting converted into NaN and B stays as it is. So when we compare NaN now with 100, as expected, we'll get false. Now let's move into the strict check. The strict check is quite intuitive, really, in the sense that it doesn't allow for the implicit conversion. So which means we'll get an equality equal to true only when both the types and the values that are being compared are equal. So I'll take the same examples that I took for the loose scenario. So in the strict scenario, when we are comparing a string 100 to a number 100, now that the implicit conversion is not allowed, we don't even get to the value part. We are essentially comparing a string with a number. And of course, a string cannot be equal to a number, right? So the result is false. What happens in the second case? What happens in the second case where there was this word 100 and then there was the number 100? We don't really get an NaN like we got previously because implicit conversion is not allowed in the first place. So string stays as it is, the string 100, and the number again stays the number 100. Again, because we are comparing a string with a number, we get the result as false, as you can see here. So that's about the strict equality. So basically, in primitive types, in the loose type, the implicit conversion is allowed, which might mean that we might end up getting NaN, and then in the strict type, the implicit conversion is not allowed. Now, let's move to the non-primitive type. What really is a non-primitive type? Non-primitive type is where the variable is not really a string or a number or a boolean and so on. Non-primitive types are where the types are something like an array or an object or a function, etc. So for this example, I'm taking examples of array to demonstrate the examples. Before getting started on the equality checks, let's first understand how the non-primitive types are represented in a memory. Non-primitive types are actually represented in a slightly different manner than their primitive counterparts. So here I'm taking two arrays, array A, which has 3 elements 1, 2, 3, and then array B, which has 3 elements 1, 2, 3. Now, how are actually they represented in the memory? We have array A. For array A, a contiguous memory location will be assigned in the memory, which will hold the values 1 and 2 and then 3. Then again, since we are creating a fresh array B, another contiguous memory location will be allocated, which will again hold the same values, 1, 2, and 3. Note that even though the values of A and B are exactly the same, they are two separate arrays, meaning they hold different memory addresses in the memory. The variables A and B do not really hold their respective values, 1, 2, 3. They actually hold the memory addresses. So A will hold the memory address of the place where this 1, 2, 3 is assigned to. And similarly, B will hold the other memory address where its own values 1, 2, 3 is assigned to. So A and B, since they have different memory addresses, their values will be different. So this is the concept that the variables of non-primitive types do not hold their value. Rather, they hold the values of the memory addresses of their values. This concept is what the whole equality or the inequality check at the non-primitive type rests upon. So let's get started. So in the first example, I am taking a variable A, which is of type 1, 2, 3, and then a variable B, which is again of type 1, 2, 3. And I'm checking their equality through a loose check. What happens in a loose check? Implicit conversion is allowed. But in this case, we don't really need an implicit conversion at all because both A and B are of the same type. They are both memory addresses. Then we can get to the value part directly. The values are actually the memory addresses of the memory locations, the memory location of this versus the memory location of this, which are obviously different. So when we compare the A and B values, we essentially compare the memory addresses. So that's why when we output the result to the console, we get false. Moving to the second part, where we have the same array 1, 2, 3 assigned to A. But for B, we don't really allocate a separate array. We just say that B holds the value of A. What does it mean in terms of memory? In terms of memory, what happens is for the first line, A will be assigned a contiguous memory location again, 1, 2, 3. But for the second line, B equal to A, nothing new is really allocated to B because we just say B equals to A. That means B is asked to point to the address, the memory address, which A is already pointing to. That essentially means that B will hold the same memory address that A is holding to. Therefore, when we compare the value of A and B now, both will lose check. It doesn't really matter whether we are comparing with loose check or strict check because implicit conversion is not really required. When we check B with A, we get the value as true. So this is how the non-primitive types behave in the loose check. To reiterate, the strict check in non-primitive types will be exactly the same because the implicit conversion of the types is not required at all. We are only comparing memory address, one memory address with another, which will obviously be of the same type. So whether it is loose check or the strict check, we'll get the same output. If we are having different arrays, even if the values are exactly the same, the equality check will result in false. Whereas in the second example, where we had a second variable pointing to a first variable, the memory addresses will be same, and that's why the check will result in true. Okay, I'll quickly cover the inequality part. Inequality, how does it look like? Again, there is a loose version and a string version. The loose check looks like this in inequality, where there is one exclamation and one equal to sign. The equal counterpart had two equal signs. And similarly, for the strict inequality check, we have one exclamation and two equal to signs. I'm not really going to go over this inequality because the result will be exactly opposite of its equality counterpart. You can try it out yourself. I'll move on to the last part, which is NaN. What is NaN? I had touched upon this when I was demoing this part where I was trying to convert 100 into a number and we got NaN, meaning not a number. When we get an NaN, NaN is resulted when we try to convert something into a number, but it's not really convertible. So here we have three variables. Variable A, which is already number 100, and then there are two other variables, B and C, which are really strings. So when I try to log the console of A, this is pretty intuitive. It's a number and I'm trying to increment the value by 1, which is 101. But what happens when I try to increment the value of B, which is a string? This is not really possible. I cannot do a plus plus increment operator on something which is a string. So in the process of trying to increment it, I actually end up getting an NaN plus plus B. So when I'm trying to log the output, I get, okay, let me run it again. I get NaN. Similarly for C, if I try to log the output of plus plus C, which is a string, I will again get an NaN. Now, what happens when I'm trying to compare the value of A and B with the loose equality check? This is a double equal to signs, which is a loose equality check. I'm essentially trying to compare 100 with, which is a number with a string. Because this is a loose scenario, loose check scenario, implicitly this will be converted. That means 100 will be converted into a number. It will be tried to get converted into a number, which ends up being an NaN. So essentially, we are converting 100 to NaN, which is obviously false, as you can see here. Okay, what happens when we are trying to compare plus plus B with plus plus C? Plus plus B will result in NaN, like we saw here. Plus plus C again will be an NaN, like we saw previously. So essentially, we are comparing plus plus B and plus plus C, and because both are NaN, what do we expect? This results in false. That means NaN not only is it unequal to the other numbers or the other entities, NaN is also unequal to itself. Even if I had compared plus plus B with plus plus B itself, even then I get a false. So this is one of the peculiarities of JavaScript, where we have an entity NaN, which is not equal to anything at all, not even equal to itself. So that's what I shared in this video. We went over the loose check for the primitive types and then the strict check for the primitive types. Then we went over the loose and the strict check for the non-primitive types. And finally, we saw how NaN behaves, how it is unequal even with itself. So if you like the video or if you have any feedback to share, please share it in the comment section. In the upcoming videos, I'll discuss about more topics on JavaScript. There will be places where JavaScript behaves in a very intuitive way. And there will be places where JavaScript behaves in a quite counterintuitive way. So that's all I had to share in this video. Thank you so much for watching.